Okay, let's dive in. We've got some truly mind-bending source material for this deep dive today. It's all sparked by a recent astronomical discovery that's, well, it's leaving a lot of scientists scratching their heads. And alongside that, we have this bold new theory offering a completely different way of looking at the cosmos.
Yeah, the material we're digging into, it centers around excerpts from something called motion theory. Specifically, a piece titled Galactic Rhythm and the Black Hole Universe.
Right, and our mission here, let's try to cut straight to the core claim presented in this work and maybe figure out what its potential implications are for how we understand, well, everything. You're going to want to buckle up for this one.
Definitely. It all kicks off with this really fascinating finding from the James Webb Space Telescope, JWST. It looked at 263 ancient galaxies, and we're talking really ancient.
Like first structures, ancient.
Exactly. Some of the very first structures that formed maybe just a few 100 million years after what people commonly call the Big Bang.
Okay, and here's the jaw dropper, right? Over 60% of these ancient galaxies, they found they were spinning the same direction.
Clockwise.
Clockwise. Stop, think about that for a second. More than 3/5 of them.
Yeah, and the significance of that percentage, it's profound. As the research points out, this isn't just, random chance.
No way.
This is statistically significant. A directional preference observed across these immense cosmic distances. The analogy they use is like flipping a coin 263 times and getting heads 160 times.
You wouldn't just shrug that off.
You absolutely wouldn't dismiss that as coincidence. In a universe we usually assume is random and isotropic.
Meaning like the same in all directions, no special up or down.
Exactly. Roughly the same everywhere, no preferred orientation. So finding such a strong uniform pattern like this is, well, it's incredibly unexpected.
So how is conventional science even trying to make sense of this? What does the source say about that?
Well, the material suggests they've mostly landed on two potential explanations. One is that there's some fundamental, maybe previously unknown cosmic structure influencing this spin.
Okay, like some huge underlying pattern we didn't know about.
Right. The other possibility, maybe less exciting, is that it's just an observational artifact.
An artifact, like we're just seeing it wrong.
Kind of.
Yeah.
Perhaps due to something like Doppler bias affecting how we perceive the spin direction from here.
But the source seems skeptical about that Doppler explanation.
It did. What's particularly interesting in this document is the critique. It argues that if the Doppler effect was simply distorting our measurements, making clockwise look like counterclockwise or vice versa, over a large sample of galaxies viewed from all sorts of different angles and distances, you'd really expect that distortion to average out.
Right. It should cancel itself out eventually.
But according to the analysis presented here, it didn't. The clockwise preference remains statistically significant, even after trying to account for those potential observational biases.
Okay, wow. And this is where the discussion gets really provocative, isn't it? Faced with this pattern, this undeniable pattern, and the difficulty explaining it with standard models. The source claims some scientists are now seriously considering something that sounds, frankly, like science fiction.
It does. The idea. What if the entire universe is somehow contained inside a black hole?
Whoa. Okay. That's a lot.
It raises a pretty wild question, doesn't it? And while mainstream thought is grappling with that mind-bending possibility, the source introduces the perspective from this motion theory.
Right, the alternative view.
And from their viewpoint, this finding isn't surprising at all. Their core claim is essentially that galaxies spin because they inherited that spin.
Inherited.
Yeah. They were born from motion that already had structure and direction.
Okay, unpack that born from motion idea for me. How does that work in motion theory?
Well, their description is quite vivid. They see every structure in the universe, from the smallest particle to the largest galaxy, basically as an echo of structured motion. The phrasing they use is loops that held, rhythms that survived collapse.
Loops that held.
Okay, so that synchronized direction of the ancient galaxies. Motion theory doesn't see it as an accident or some imposed force. They see it as a form of inherited synchronization.
Like ripples from a bigger splash.
Sorta. Think of a large, stable whirlpool spinning off smaller eddies. Those smaller eddies naturally retain the rotation of the larger system they came from. It's described as motion collapsing and refining itself into stable, self-perpetuating patterns.
Fascinating. Okay, so connecting this back to that black hole universe concept, how does motion theory view that idea? Is it compatible?
They look at what mainstream science might label a black hole universe, and while the description of a contained system isn't necessarily wrong from their perspective, the interpretation is fundamentally different.
How so? What's the difference in interpretation?
Well, to conventional science, the source suggests that black hole universe idea often implies a kind of gravitational trap, a singularity, maybe an endpoint or a boundary.
Right, something you fall into.
Exactly. But motion theory describes large-scale reality as a motion cascade converging to maximum rhythm density.
Okay, motion cascade converging to maximum rhythm density. That's a mouthful. What does that mean in planar terms?
Yeah, it is. Think of it less like a trap and more like a recursive process. Motion folding inward, concentrating itself, refining, syncing up.
Okay.
Like multiple waves interfering constructively, to build a stronger, more stable wave pattern. Or maybe think of a complex fractal pattern that keeps repeating and refining itself at smaller and smaller scales. In this view, motion isn't lost. It converges into tighter, more stable, more dense rhythms.
So rhythm density is their term for how concentrated and synchronized the motion gets.
That's right, how much stable looping motion is packed into a structure. And this process of recursive folding and convergence, they argue, leads to new layers of structured reality.
So, if I'm understanding this, they're saying, yes, maybe we are in a contained system, in a sense, but it's not a gravitational trap you fall into and can't escape. It's more like being inside a giant ongoing process of motion organizing itself, organizing into these incredibly stable looping patterns.
You've got it. The source puts it this way. We're inside a colossal self-stabilizing motion loop, where even galaxies remember the spin that birthed them. They're fundamentally challenging the idea that vast structures like galaxies just randomly formed out of primordial soup and then somehow acquired spin later.
Right, the spin comes first, or is inherent.
And the observed fact that over 60% of these earliest galaxies are spinning the same way, defying randomness across immense scales, that's their key piece of evidence.
Their view seems to be that just assuming randomness as the primary driver, it doesn't actually explain the structure we see.
Precisely. Motion theory argues that randomness doesn't generate stable structure. It's recursive, self-organizing motion that does that work. You don't get balance and order from pure chaos alone, but from inherent constraints and dynamics within the motion itself that lead to self-synchronization.
Okay, so let's try to wrap up the core ideas from the motion theory perspective presented in this document. First, that observed galactic spin memory, it's really inherited synchronization from some larger, earlier process.
Correct.
Second, what mainstream science might tentatively call a black hole universe. From their view, that's more a description of recursive motion converging, folding in on itself, and increasing its rhythm density.
Exactly. Not a trap, but a convergence.
And third, the fact that standard explanations like Doppler bias seem to fall short, that highlights the limitations of maybe outdated, too linear models trying to explain this deeply non-random observation.
Yeah, it suggests we need different tools, a different framework, and it entirely shifts the fundamental question we should be asking, doesn't it?
Ow.
Instead of asking, why do galaxies spin this way, which sort of implies some external force or random event made them spin, motion theory compels us to ask, what original skin structure birthed these galaxies?
Right. Where did the spin come from originally? And their proposed answer, as we've discussed?
The inherited rhythm, the memory of the larger loop, the larger pattern that started it all.
Okay, so while conventional scientists are actively debating this possibility of our universe being inside a black hole, the material from motion theory leaves us with a different kind of thought experiment to ponder.
What if the universe isn't primarily a product of randomness at all? Or just, a potential gravitational trap we happen to be in?
Instead, what if it's more like a beautifully synchronized system, constantly refining itself, carrying the memory of its origins in the very spin of its galaxies?
Yeah, a system looping and repeating until its fundamental rhythms kind of lock into place, generating structure not from chance encounters, but from inherent self-organizing motion.
A system where motion doesn't just happen, it never stops dancing.
That's a great way to put it. A cosmic dance of recursive loops.